Good afternoon, everyone. Thank you so much for joining us. I am Pratik Vishwakarma, co-organizer at AWS User Group Indore. And before we begin, a little announcement. If you have any questions or query, please feel free to ask them in the chat box. And moving on to our session for today. So today we are learning about generative AI services on AWS. And to cover this topic, we have Saurabh Chaudia sir with us. He is a solution architect at Wipro. With a remarkable background spanning over 13 years, his expertise lies in SAP, HANA, OSDB migration, cloud migration, and implementation. He is currently a vital member of Wipro's cutting-edge solution team. He holds certifications such as AWS Solution Architect Professional, AWS Specialty certifications like Machine Learning, SAP on AWS, SME, and expert level certification of other cloud platforms. And trust me, he holds many more. And this underscores his expertise across a range of platforms and domains. So I would like to request Saurabh Chodia sir to enlighten the community members on our today's session.
Okay. Yeah. Thanks, Pratik. Thanks for the introduction.
Yeah.
Hey, hi, everyone. Glad to be here with everyone presenting one of the very hot topics that has been going on with the introduction of ChatGPT few months back, which is generative AI. So, without wasting any time, let's jump into this and do let me know if there are any questions in the chat or I don't know, Pratik. Can it be a verbal question or will it be on the chat only? Or can somebody unmute and ask as well?
Oh, they can use the chat box.
Yeah, okay. So please use the chat box wherever required. Yeah. So what is AWS generative AI? To understand this, first we need to understand what is AI and what is generative AI in the first place, right? So sorry. So you see a diagram or an image that I have taken from the AWS content itself, which basically is a very brief view of what generative AI is all about, right? So it can basically generate all the blue circles that you see on around the center circle. It can generate text for you. It can generate music for you. It can generate chatbots, images, whatsoever, right? Videos. I mean, the possibilities are becoming limitless as we go along. Okay.
Hello, we can't hear you, sir.
Hello, can you hear me?
Yes, yes. Yeah, we can.
Sorry, but there's a problem with the headset. I've switched to a different one. Yeah. Okay. So as I was mentioning, this is what generative AI can do as a as a tool, as a product, whatever we want to call it, right? Let's jump into what is generative AI. Right? So generative AI or Gen AI, as it is popularly known, is a substream of AI and ML, right? Artificial intelligence and machine learning. So I would just go to very basic. What is artificial intelligence in itself and what is machine learning, right? Artificial intelligence is a is a technology framework, a stack that has been there for almost 20 plus years now, but now it has been gaining more and more maturity, wherein we are getting machines, computers, to think how humans usually think, right? So they can take their own decisions, and then they can basically do things that usually a human will do, like robots doing some sort of warehouse pickings, these kind of basic stuff, and then they're gaining more and more maturity. How do they do it, right? So obviously it's a machine, it doesn't have a brain on its own. So how does it do it is what artificial intelligence technology is all about, and at the core of it is machine learning, There are other things within AI called deep learning, other aspects, but we will focus on machine learning for now. So machine learning is basically how the existing data can help you decide what the future would be. I'll take a very real life example, right? So how does a kid learn? Now we all speak Hindi, for example, in our region our kids learn Hindi. How do they learn it? They learn it by seeing their elders. This is the same thing that machine learning has used to be developed further. Okay, so basically in machine learning we give it a lot of data, and on top of that we put algorithms which then tells the machine that what could be the next output, right? So when you now type nowadays in your mobile, and you will automatically get the suggestions. How does it come? It has come because for these many years whatever data has been typed is given as an input to this machine, and there are models created which can tell that, okay, if you type WELC, welcome would be the most probable word, right, as a next word in the chat, in the what you call mobile typing dictionary. But this is very basic example. Okay, I'll tell why generative AI is different now. So generative AI focuses on generating text, audio, images, and synthetic data sets, not only for a single word, but generate a lot of text. When I say a lot of text, things like blogs, right, or things like automatically generating a lot of code to create some. I mean, for example, you want to create an app and you want to create it on some sort of JavaScript, and you don't really know JavaScript, right? For example, I don't know JavaScript either, but I still want to create some content there. All I have to do is I have to tell Gen AI in simple English that this is what I want to do. It will look into the repository of codes that are open source like GitHub and various other sources, and it will try to be more accurate, as much accurate as possible, to give a working code back to you, right? This is what Gen AI is all about. So it is not a single word or a single sentence. It can generate the whole blogs or the whole set of codes. And then there are different applications coming in for audio, images, even generating synthetic data sets, right? So why we need synthetic data sets is an important concept in itself. The synthetic data sets allow machine learning to get itself even better, right? Because for many domains we only have limited data, right? For example, if you want to do a research for something in Africa, kind of continent, right, not everything is digital over there, so you don't have a lot of data. So that is where uh, a use case would require some sort of data, and on top of that you need to create a lot of synthetic data. Yeah, that's what Gen AI is all about. The next term that you would have heard a lot, which is what I wanted to deep dive on, is LLM, large language model, right? They are basically trained on trillions of parameters. Now what is parameters? I'll come to that in the next slide. But they are trained on millions of parameters, and because of the scale that it has been trained on, right, there were models even before this, but because of the scale it has been trained on, it is now taking this AI whole ecosystem to the next level. When I say the next level, not only a single word suggestions, but generating all sort of blogs, and then you would have read in newspapers clearing some sort of basic exams as well. All of those things are happening because these models are having lot of parameters, lot and lot of inputs and outputs, which basically allows it to uh, do what a Google search would not usually do, right? Google search obviously was powerful, but this has taken that power to the next level. There are a couple of powerful large language models. In fact, there are more now. If you ask me, all the leaders are generating GPT that has been come from OpenAI. We have BERT, bidirectional encoder representation, and then you have BARD coming from Google. AWS has its own tool sets that we will go through in the next few slides. All of these, basically what they are trying to do is they are trying to use all the data that has been collected, and how fast we can get some sort of output for our use case, right? The use case can be anything. The case can be, how do I make some sort of recipe, right, for a food? And then it will go and search all the repositories of the existing available internet based data and try to find out how it can generate this recipe for you. And the output will be created in a textual, readable, common language, common man format, right? So like how humans as we understand it, or even taken a step further, right? How somebody who is of our parents age, who don't really have that much hold on, let's say, English and on computers, would understand it. So that kind of output is what Gen AI is trying to achieve, and there is hence a lot of opportunities as well. So why I picked this topic is I wanted to also tell that this is having limitless opportunities, because for example, things still happen in English here, right? We as a country are ourselves such a big number of people that this has a lot of use case if it can be done in Hindi, but there's not much that has been done on our language right now. So once it is there available, it can reach to all our small villages, and people who are already having mobiles can do much more about it. Yeah. So next is terminology. I skipped a couple of key terms in the previous slide because I wanted to cover them here. So terminology wise, I wanted to touch a few words that you would hear. There are plenty of terminologies, okay, or terms rather, that we have in a machine learning AI space, but these are the ones that you would really touch upon if you are getting into Gen AI space. Okay, and there are much more. So if you get any other terms, yeah, I just have picked the top ones. The first one you read here is generative adversarial networks, GAN. This is from a paper that was published in 2014. What this paper did was, by then machine learning was already having a lot of algorithms, right? It has created a a model that actually has two algorithms who always compete against each other. One algorithm generates some sort of outputs, some sort of text or images, and the other model tries to find whether it is a real or a fake image, right? Or a real or a fake text. Fake text, by that I mean it is not written by human. That way, by competing these two models, right, it is like a simple two player badminton match, for example, right? Everybody tries to win, so the both the models try to win, and the output of this GAN network, which is now becoming actually core of a lot of these models that we see, LLM and all this stuff, is actually giving you a better result, a better and better result, because this is happening behind the scenes every time there are two algorithms competing, and they are giving you an output differently. Hence the beauty of Gen AI, unlike Google search, is you get every time a different output. Okay, so if you ask a simple English question, the way the answer would be framed will be different in most of the cases. The reason being, again, because it always tries to put different outputs as a generated output, and uses one of them as the output that can be displayed. The next term that would also be something that you would have come across is called prompt engineering, which is basically what should you give on that prompt, right? So this is actually something that people who are familiar in IT, right? For example, I have been 14 years now, is very it's very important for us to know is what to type on Google to get an answer, right? We know not none of us write a code from scratch or troubleshoot a problem from scratch. We do a Google search, we try to find something. What to type is an engineering in itself. It's a very important thing, and people who learn this and do this smartly are actually the front runners and the pros in IT. The prompt engineering is the same thing applied on a Gen AI model, right? So how do you type the input so that the output can be as precise as possible, right? You can type it in n number of ways, right? So let's say you say that, okay, I like a specific I like pav bhaji, for example, right? And how do I make it? And then you can also say it in a way that please give me a recipe of pav bhaji. Both of these basically would have the same output, but the second question would be having much precise output because we have specifically asked a question. That is what prompt engineering is all about. And there are two domains within prompt engineering. So one is telling the user to type it in a more precise way, and second is even if they don't type it. So if I am, let's say, I'm a pro in IT, or I know these prompt engineering things, I would type it precisely. But there are people who don't really have any background of IT who want to use these technologies. For them, another branch by itself is how do we change that any input into a more precise input that can be read by the background algorithms. Yeah, so that's what prompt engineering is all about. The parameters. Now this is the thing that you would have seen in the previous slide, right? They are basically the actual core part of the model, right? They are the stuffs that are learned in training. When I say training, when we run any algorithm in machine learning, there are two phases, right? Training and inference. Training is when you give it a lot of data to let it understand some sort of meaning out of that data. So if I say that, okay, my name is, sorry, the algorithm is also trying to learn the relationship between these words, right? My name is, it is not a r after that, and it will find this in thousands of sentences. It will learn that grammar by itself, that if there are sequence of words called my name, the next word would be expected is. That is what basically parameters are all about. So all of these specific single word learnings are what basically the parameters are. And hence it creates a mapping between input features and output labels. So in machine learning, anything that you give as an input is a feature, and anything that is expected as an output is a label. So the chat gpt 4, which is actually not out yet, right? Chat gpt 3 is what we are primarily using, itself has 170 trillion parameters. Okay, 170 trillion, you can think of the scale and the machines that would need to run behind it to actually consume these parameters. Yeah, so that's what parameters are. Foundation model is very important, another term that we will go into, what aws services have to offer on foundation models. But on a high level, a foundation model is a large machine learning model. So in principle, it is a model. It is a set of code. If you don't, basically, even the model word is a bit confusing, right? So it is a set of code which is based on some mathematical principles. So behind all of these is basic mathematics or high level advanced mathematics that we would learn in schools and colleges. And it has been used to train on a lot of data. Okay, so, and using that, it can adapt to large variety of tasks, use including the large language models. So that is what foundation model is all about. We'll look at a couple of foundation models in the later slides, and also I have just opened up a few demo sessions that we can actually just walk through. Yeah, so that's what foundation model is all about. Now the four terms are also important. So these are part of foundation model itself or llm itself. The first four were more technical components of ai ml. The bottom four are more in-depth foundation model. What does it have? So in this, what we have is called an embedding layer. Okay, the embedding layer is basically to convert a text, a word, right, into a high dimensional vector. I don't know, I mean, the background probably of most of you, but I would assume that you know vectors. They are basically a collection of data that you would store in a tabular format. In simple words, right? Vectors you would have read in your schools and colleges. Now each word, or for every paragraph that you give it to this machine learning algorithm, each word would be stored in this high dimensional vector. When we say high dimensional, because it stores for each word what is the previous word, what is the next word, and like this up to a length, right? Up to the full stop, it will try to store the previous and the next word. That's why it is high dimensional vector, because it creates a 3 by 3, 5 by 5, even n by n, for very large number as a matrix. And that is where it learns from this data, right? So how would machine learn is basically by creating these kind of vectors. So hence there is an embedding layer which will help machine learning code or the foundation model to capture the semantic and syntactic context, right? It's not only that word, but what is the meaning of that word in the whole paragraph, in the whole sentence, is what embedding layer is going to do. The feed forward layer is multiple layers that are basically connected. So multiple such embedding layers are then connected, and then what we do is apply a non-linear transformation. Now I know these are very complex words. If I go into each of them, it would take probably another 5-6 hours. So we can have a deep dive on machine learning itself, but I would keep it high level at this stage. So feed forward layer is basically what helps the model learn from these embedding layers, right? It basically uses those vectors to create the learning and then give that output to the next layer. That's why it is called feed forward layer. Recurrent layer is basically what we just mentioned about one word here, embedding layer, right? If you now think about multiple such layers, that is where recurrent layer will come into picture. It's a combination of a lot of embeddings, right? Because there are sequence of words on all of that combined, what does it mean is what recurrent layer captures. It knows, by maintaining a hidden state, it knows what is the dependency between I and M and and sort of, right, these four words in my example sentence. It will know by reading many such sentences what is the what is the correlation between them. Attention mechanism, now this is an important area that is now under a lot of research as well. So in case you're interested, probably we can deep dive on this in some other session. But attention mechanism helps model to understand what are the important words, right? So if I go back to very basic school English, we'll have verbs, nouns, adjectives, all of these things, right? So which of these are important? I My name is Saurabh, right? My and is are not that important. Name and Saurabh are important in this whole sentence. That is what attention mechanism do for you. Attention mechanism tries to find what are the important words in that sentence, and then it generates more accurate predictions using that. Okay, so that's what attention mechanism is all about. Yeah, so this is the background from I would say a bit of what we should know before we try to use Gen AI, right? So all of these are basis of Gen AI. Don't worry if some of these terms are not something you understand, right? Because it has taken time for me, it has taken time for everyone, and it many of these are under research still, right? So uh, the good part is, if I now move to the next slide, we'll probably take questions at the end. The good part is that all of these stuffs are available from AWS out of the box. So you don't need to really worry about creating a model from scratch, worrying about the embedding layers, all of these stuffs, right? So none of these mechanisms, foundation models, you don't really need to worry about it as an individual, or even for your company. If you're creating something, you don't need to worry about doing anything from scratch, because Amazon has given a few solutions that allows you to consume what has already been developed. How do we do it is what I would cover in the next few slides. First one of these, which is still in a preview, is named Amazon Bedrock. Right, the foundation models are already available via Amazon Bedrock through an API. Right, so you can just make a very simple call and get a response via this Amazon Bedrock. Right, so let's say you want to do something like a chat GPT on your own website, right, or on your own app. You can basically use Amazon Bedrock service, make an API call there, and for your specific use case, right? I mean, let's say a very simple example, right? You are We all use big basket, right? So in big basket you want to introduce a new feature that if I have to make, let's say, a pav bhaji, again as an example, sorry, it's my favorite, I keep repeating it. Then how do I do it? I don't want to order one by one every item in big basket, right? I want to let big basket tell me, okay, I will need the salt, I will need the masalas, everything, and please order that for me. Now think of it, right? It is a very innovative use case. I don't really need to worry about what all I even need. I just tell, I need, this is a item that I want to create in my I want to cook today in my house, and please order me these. You will basically be using Amazon Bedrock, making an API call to it, and your whole text, I want to make this, would go to Bedrock. It will search all the data, try to find ingredients, and give you as an output back on your big basket screen. These are the items that you need, right? 7 or 8 items. Please order these, right? Now, this is very different from what we do today, right? Today, you will probably call your friend or your mom and ask them, what do I do if I have to have pav bhaji? Or you probably will go to a nearby store and just buy it as a cooked food. But again, different use cases, right? So if somebody really want to cook, this is what they can do. Now, foundation models are made available in Amazon Bedrock via some startups, including Amazon themselves. They are basically having their own models, and they have also collaborated with AI 21 Labs, Cloudy, Stable Diffusion, and then there's a internal Amazon project named Amazon Titan. All of these have their own models, right? So see, they are all foundation models, but they work slightly differently and they answer different use cases. Behind the scenes, every model or every algorithms here will have pretty much the same things that we saw in previous slide, right? The embedding layers, and then you will have to do all this prompt engineering. But that is all happening behind the scenes here, and obviously if you want to customize them, there are options. However, they are all available on Amazon Bedrock. So they are privately customizable. Now that is the beauty here, right? You get those models and then you can customize them as well. You don't really need to worry about the data being on public domain or uh, some sort of security problems. All of these are not a worry anymore because they're all privately customizable. You can integrate and deploy with SageMaker. Now SageMaker is something, if somebody has been in touch on AWS AI ML space, they will know SageMaker is the baseline for machine learning or AI in AWS, right? If you go to console search SageMaker, it will have plenty of services behind SageMaker, which allows you to integrate and deploy other tools like S3 buckets, EC2 instances, all of that into SageMaker. The data remains private, as I mentioned. And the last point is very important, right? So there is a built-in detection and removal of harmful and inappropriate content. When chat gpt became popular, there was also a lot of news around its negative impacts, right? So somebody might be searching some explicit content, right? Or some sort of a very wrong direction thought, like I mean, let's say I probably should not use the word, but how do I use poison, right? Now this is a negative sentence which we would not want a customer to search on big basket example, for example, right? So I would want to remove that question. Even if somebody asks, it should be removed. How do we do it? Again, there is a built-in detection and you can customize that on top of the built-in content that you have. That's what Amazon Bedrock is. We'll have a quick look on the screen. Again, Bedrock is in preview, so only customers who have signed up are actually able to use it. Hence, I would not able to show the full demo, but yeah, that's Bedrock for you. The next one is named Code Whisperer, right? Amazon Code Whisperer. All the developers who are there in this call would really love this tool. The reason being, it allows you to do the coding in a much simpler manner, right? The coding, when I say, whether you are writing JavaScripts, Python codes, whichever it is, right? Code Whisperer is a coding companion. It gives you suggestions, just like how when you type in your daily chats on WhatsApp or Teams, right? It gives you the next word. The Code Whisperer actually gives you the whole code as a suggestion. If you just want to type it in a very simple English, couple of lines or words, it actually converts that into a code in all the popular languages. How does it do it? The same theory which I mentioned. It has basically learned this based on the comments and the codes that have been put in on GitHub and all the open source repositories, and then it generates real time code suggestions. That's where it basically becomes a useful tool. Another important thing which I think I have not put here is it is actually free for the developers. Okay, so only if there is an enterprise usage, AWS is charging you, but as an individual developer, if you are using it, you are actually free to use it. I'll show a live screen of the Cloud9 IDE that AWS have, right? So over there, how this Code Whisperer comes into play. But it is very easy to use, free to use, and it supports all major programming languages: Java, Python, C sharp, plenty of them, JavaScripts. So how does it happen? You just write a code in the IDE, and then the code is sent to Code Whisperer service. It does all the security scan, reference tracker, and bias avoidance. All of these, the right side in the orange dotted box you see, is happening via machine learning. And then you get back your code recommendations on your IDE, the development environment that you have. That's what Code Whisperer is for you, right? So it can really, as the name, AWS has been very good at naming them in very nice words, right? So Code Whisperer actually can listen to your code and then just give you new code. That's Code Whisperer. The next one is Amazon SageMaker. I'm sure if you have got some exposure to AI ML and on AWS, you would have been aware of SageMaker. But for those who are new to this or new to AI ML but are interested, SageMaker is the place to start, right? SageMaker and all the I mean, it covers the breadth of machine learning. Everything that you would think of can be done within the SageMaker. The ML models, as I said, Gen AI is one domain, right? It is generative artificial intelligence to generate some content, but you also have a lot of ML models for other use cases, deep learning, robotics. They all are not generating outputs as text or images. They have different use cases of their own. It covers SageMaker covers everything, right? It is a fully managed platform, right? So you don't need to really deploy anything on your data center as with any other AWS service. Everything underlying from an infrastructure layer is fully managed. The platform itself is fully managed by Amazon for you, and you basically have to just worry about performing your ML task. So what is your use case, what language you want to use, how do you want to train the data that you have, and whether you want to clean the data. All of those things are basically available via SageMaker. It has very nice monitoring and debugging features, right, which basically allows you to, in any language, primarily you would have heard about Python or R, but then there are other languages available as well, which allows you to create machine learning models. All of those, not all, rather I should use, most of those are supported, and the code can be written in Jupyter notebooks. Now Jupyter notebooks, if you guys are not familiar, is a place where you write most of these machine learning codes at the very basic level. It is a mix of normal English text, and you can also write the actual code here in Python, in other languages. It is available as part of SageMaker. So if you have to use SageMaker, right, what would be the typical flow? Again, the images right from AWS page itself. You would first have to do the labeling of data, right? Labeling of data, what does it mean? Now we have been talking so far about Gen AI can understand the context, right? My name is Saurabh, it can understand the relation between the word. But for that we have to label that data, right? When I say label, if is a verb in this sentence, right, or mine is a my is a pronoun, how does machine know it? It has to be first labeled. It has to be told by somebody. Or in case of images, right, for example, now in your Facebook you will usually see a recommendation saying, okay, if you want to tag a friend with their face, it will just find that this friend is so and so. How does it do it? Because there's a lot of labeling of data happening behind the scenes, wherein somebody is actually going on there and tagging that data, saying that this is a nose, this is the lips, these are the ears, and that is how machine is learning. There is also a new pattern with the label data that is now coming, which is basically labeling automation by itself, right? Machine learning itself labels the data, but remember that machine has no brain of its own, right? So it need to have some starting point. Once it has that starting point, it can then do more labeling on its own. Once you have labeled the data, either you want to do active learning or human labeling. uh, when I say active learning, it happens by itself, as I mentioned, and human labeling is what is more popular for any new type of data which is not already labeled. And then once you have labeled, you would want to build something on top of it, right? You want to build a model or build a combination of service. For example, your data would usually be 100,000 rows or even millions of rows. That's where machine learning actually comes in handy, right? So where would you store it? In AWS, it would be, the go-to place would be S3 buckets, right? So how in build phase you connect those S3 buckets onto your SageMaker model. The next is training, right? When we do training, we basically run those algorithms, the code that we have thought will be helpful, and then using those algorithms, frameworks, whatever we want to call it, you do a training process which tells this whole algorithm that my is a pronoun, is a verb, all those things, right? That's what training is. Tuning is basically making this whole process better, right? So because remember, machine learning is or was and will never be perfect, right? It's a continuous process. You will always be chasing more and more accuracy, but it is, in my opinion, the brain can always think much farther than a machine can. So tuning would always be a continuous process, and more models, more and more ways it will be we will be finding as humans to tune this. Once you have tuned it, you will basically deploy, which is basically you are creating endpoints, SageMaker endpoints, which can be called by, for example, the Big Basket app kind of example I was telling, wherein you will be able to do real-time predictions. The other thing you can also do is, obviously these five are if you want to do things from scratch. Most of the times you don't do it from scratch because there are already models available, readily usable for free, for some paid services if they are more advanced ones, and they're all available via AWS Marketplace via the Discover feature. Okay, so that's SageMaker for you. Uh, in context of Gen AI, there's a specific thing in SageMaker that I wanted to talk about is SageMaker Jumpstart. Yeah, so SageMaker Jumpstart, as you would see on the screen on the right, this is SageMaker Studio. It's basically the foundation models availability, all the open source models that are available and pre-trained are available for you here for further tuning. We'll have a look at it at one of the models. We cannot run it because of the free account limitations, but we will go through that model and you can see what you can get out of it, right? So it is accessible via SageMaker console. That is what people would use, but somebody is more familiar with developer tools, it is also accessible via the Python SDK. Very useful for people who are getting started and building some demos and POCs. Uh, those kind of use cases is where the SageMaker Jumpstart, the name itself is named that way. Again, Jumpstart is to kick off your journey on machine learning, right? So all these foundation models are available here. So what is Bedrock versus what is Jumpstart, right? That thing might have come to your mind by now. The Bedrock is basically making an API available, so you don't need to worry about the model at all, right? The model will run behind the scenes. You will make an API call. Whereas Jumpstart is more getting into the developer area, right? In Bedrock as well, you would do it, but it will be more enterprise use cases. That's where Bedrock is aimed at, right? Whereas SageMaker Jumpstart is more aimed at some sort of demos, POCs, these kind of scenarios. They will have overlapping usage for sure, but that's how the SageMaker Jumpstart and Bedrock have been differentiated. Yeah. Okay. So I'll move to the next one. You will see two more terms that are important. If you go to the Gen AI page of AWS as well, they will talk about Terranium and Inference. These two terms, what are they? Again, they are very deep technical. If we want to go into deep, we can probably spend hours, but I would not do that right now. Already, yeah, I think we are already around 40 minutes. So Terranium is EC2 instance. In simple words, it's a customized EC2 instance, just like you have your M series machines or those kind of things, right? E series. There are different machine series that are available from AWS side. The Trainium instances are customized instances built for machine learning training process. The machine learning training process and inference process, as I mentioned, are two different phases, right? When you train, you actually give the data so that algorithm can make sense out of it, and in inference you give it unknown data so that it can give you some sort of meaningful output out of it. The training instances or Trainium family are basically supporting faster training with 16 Trainium accelerator. Trainium accelerator is basically an underlying, in simple words, I would call it CPU, right? Although it's not a CPU in real sense, it is a customized processor that AWS has developed for us, which allows the instances to perform much faster, right? So all those accelerators are built in on the chip, and they use what are called neuron cores, right? Neuron cores are again something that have been developed specifically for machine learning, right? They have more memory available on the chip itself, which allows you to do faster machine learning, right? I mean, you would wonder sometimes, chat GPT kind of thing, you type it and the response comes. Now the response time of that output while you type it is becoming more and more important. The faster you give an output, the easier for the end user it will be to consume that. That's where Trainium Accelerator would be useful for training purposes. For the techies, it's basically having 32 GB of high bandwidth memory, and the accelerator can deliver 190 T flops, right? So trillion floating point operations as in a second. Think of it, 190 trillion floating point operations per second is what it can deliver for FP16 BF16 compute power. Now, for the people who are interested, FP16 refers to the 16-bit floating representation, and BFS B float 16, which are widely used in machine learning. How do you represent the data on the chip, right? You would have from your data structures, you would remember that the 8 bits or the 16 bits can be used to store either all decimal values, either or uh, all the non-decimal values. So that is where the BF16, FP16 all come into picture. I have put the link of more information about how these terms are used, or what they mean rather, right, at the end. But that's on a high level what Trainium instances are for you. Remember that they are a family of instances. The more training power you need, the more powerful Trainium instances are available. They're available just like normal EC2 instances. Obviously, you will need to have a enterprise account to use many of those machine types, and you will need to check which region you want to deploy. Not every region will have all the Trainium instances, but yeah, that's Trainium instances for you. On the right, you see again an image which depicts how these Trainium instances are structured. There are vector engine and scalar engine, which basically are the computing powers, right? So vector engine processes the vectors we spoke about. Scalar are for the direct linear calculations. uh, I don't know how many of you are familiar with tensor engine. Tensor is a item, a technology developed by Google in the, and then they made it open source. So TensorFlow are a popular thing with AIML experts. All of these are combined on this chip, and you can just use them. Okay, so again, in depth, we probably don't have enough time to do that, and also it would be too technical at this stage. The next is AWS Inference. They are similar, you would see, right? The image on the right would be looking very much similar to the Trainium instances are for training. The Infertia are meant for inference acceleration. More, most probably you would end up using Infertia more regularly than Trainium, unless you are having a new algorithm being developed where you want to train it. You can actually have Infertia where you can do inferences very quickly. Okay, so they are having 12 Infertia 2 accelerators. Infertia 2 is the part of INF2 family of accelerators that AWS developed. Again, similar thing as Trainium. There is a custom CPU, or if you want to call it GPU, because it's an advanced form, right? It is actually processing those graphical processing units. That is what are built onto the chip level for the Infertia instances. Yeah, so that's what Infertia is all about. They are used in large scale Gen AI applications. So probably if you go to an enterprise case, use case where you want to do inferences quite regularly with your model, you might have to choose one of these INF2 family instances depending on how many parameters you have, right? So as we were discussing, there will be billions of parameters. We saw 170 trillion that GPT-4 has already reached. So how does all of that fit in onto a chip, right? Or a set of chips, or CPUs or GPUs? That is what AWS Inferentia brings for you. Yeah. The next is AWS Neuron SDK. So this is basically a compiler, runtime, and profiling tool, as as the definition says, or rather, in simple words, it's a set of software development kits, a framework available via AWS, just like you would have heard about other SDKs from AWS, but dedicated for machine learning, especially Gen AI, on these newer machine types, which we were seeing in Fersia and Trainium servers. And it has native integration with the popular technologies like PyTorch and TensorFlow. It just works in combination with everything that we discussed so far. There is native support. That is the most important thing for Trainium and INF2 instances, enabled by default. which would mean that you can just use Neuron SDK, and you can be sure that you can play around the newer instances types, to the debugging and monitoring very easily. So how would your flow look like now, right now, with all these uh, uh, terminologies or technologies that we discussed so far? You will basically have to first choose an ML framework, like PyTorch, TensorFlow, any of these popular ones. You'll have to choose that, and Neuron SDK supports all of them. You will have to then build your model, in case you are building it, right? Obviously there are ways, as we discussed, where you don't even need to build a model, but if you are building it, you will build it on Jupyter notebooks, that can be hosted on EC2, SageMaker Studio, anywhere else as well, right? So when I say anywhere else, they can be also notebooks from on premise, as an example, or other cloud providers. You can even use those notebooks over here. Then you will do a training on trn1 instances we spoke about, and test them, right? So you will use a neuron enabled ML framework and test and train on trn1 instances. And then yeah, you can use any of the MLOps software, so SageMaker, EKS, ECS, all these underlying AWS technologies are available for you to train and test. Once you have trained and test, you will deploy it on the INF1, INF2 family instances. That is where your inferences will come into picture. Again, they are available as part of EC2 instances, as a what you call virtual machines itself, EC2, right? Underlying VMs. You can also use EKS, which basically are Kubernetes clusters, and a lot of other features, right? So container services from ECS, AWS batch, all of these underlying can run INF1 and INF2 instances. Yeah, so that's Neuron SDK for you. The next thing I wanted to do was, I just wanted to show you a quick view of Code Whisperer, Bedrock, and Jumpstart on the AWS console itself, right? I think we have around 15 minutes. I'll take 5 minutes to show you these screens and some use cases, and then probably the last 10 minutes we can have for any sort of questions. So this is Amazon Bedrock for you. Amazon Bedrock is basically available as you would see for preview. I mentioned that earlier as well. It is the easiest way to sorry, 1 second. Yeah, just wanted to make sure that my screen is still shared, right? So Amazon Bedrock is as an API based framework or utility available for you via Amazon. It is only in preview, so I have signed up myself as well, but as of now it has not been approved. The benefits, that is what I want to talk about. Right, you have the capabilities to do text generation, chatbots, searching, any custom question based text summarization. This is very important use case. So you have a lot of content available, and you want to just create a summary out of it. Image generation and personalization. So these are the things that with Bedrock you can do, and you have all the four providers that I mentioned earlier that can give you a lot of models. Some of them we will be able to see in a couple of minutes in another service, but that's Bedrock for you. Yeah, these are the foundation models that are available. So obviously we cannot see or try them in Bedrock unless we are signed up for the preview, but you can also use them within the SageMaker, right? So in SageMaker you wanted to uh, use one of those models, then they're available under the Jumpstart. We just saw about this, right? So FM are a part of SageMaker's Jumpstart, and then you have a lot of these foundation of models available from Falcon, Bloom, Stable Diffusion. Sorry, I mean Stability AI is the company name. Stable Diffusion is how they name it. There are other SageMaker services. You will see them on the left side, right? So Jumpstart, Governance, Ground Truth, all of them have their own use cases. But I would just want to touch upon Jumpstart foundation model for now. One of the things that is coming and becoming very popular is image generation from text nowadays. Okay, so we'll see a blog as well, and I'll show you the notebook, the code which actually allows you to generate an image from text. Now, I remember those news articles and papers and all that says that something like Leonardo da Vinci's that popular image of Mona Lisa is now created via code. Uh, so those kind of things are possible now. how they are possible is what these models basically tells you or does for you. Okay, so I have basically got open a notebook which has a stable diffusion 2.1 base as a background or as a code base, and that's what I have opened in another session. So the notebook is available. I have opened it here. This is the SageMaker Studio for you, and you will see this notebook allows you to do a text to image generation. Yeah, so it can basically convert your text to image. Uh, if you are doing it on your own trial, the free AWS non-enterprise subscription account, AWS account, then you have to remember that not all machine types would be available. For example, it was not available for me either, and I had to change machine type over here. So when it says instance type, by default it was using a higher configuration that is not available in our trial accounts. But if you can use ml.p3 medium or ml.m4 x large for the uh, prediction service, then you should be able to use this and generate some outputs. I was able to run this notebook at least to generate output, but then it had a couple of other limitations to be able to actually predict the outputs because of the capacity, right? So see if you have an enterprise account, and then you can actually very easily run all of these steps. The important parts I wanted to show was, for example, here they are doing this as a text input. That is what you would do in your application directly, like the big basket application, right? You would give that text cottage in an impressionist style, and then it should just tell you all that outputs. In our case it was text, but maybe if you want images it can show that as well. The inference parameters that are supported are described here, right? So you see prompt, that is part of the prompt engineering that we were discussing earlier. Then there are a lot of other parameters which are something that you can customize. Then you can compress the output. Prompt engineering is a section in itself. We discussed about negative prompting. Okay, so that's an important area in itself. We want to exclude something that is negative. So for example, this prompt says that Emma Watson something something they have described, and they would want to treat this as negative, right? So the actress image, they don't want it to be generated via this code. Then you would have to tell your code that these are the negative terms, so that it should not basically generate that kind of output as part of the code. That's what negative prompt engineering is. It is a research area in itself, right? So what is negative and what is positive is different. Something that could be negative in a medical field, negative in a general communication would be positive in a medical field, right? So that is the kind of challenge here. So that's how you can use the models. There are all of these models available. You can very easily open them. I'll show you the output. So this is a very good blog. I have put this at the end of slide as well, so that you have the link. With this stable diffusion models, this is what you can generate. So all of these images, right, they have not been created by anybody as an artist or even customized on a Photoshop. They are generated via this model. The first one is a photo of astronaut riding on a horse in Mars. So what is Mars landscape looking like? It is what is known to this model based on all the images, the 100,000 or million trillion of images, I would say, that are there behind the scenes. What is a horse? It has shown, and then how an astronaut looks like, it has shown, and it has combined them. The same applies to painting of New York City and a dog in a suit. So these are the images that it can generate. And if I go down here, right, so you have a lot of images generated. This is the negative prompt we are talking about, right? So you would not want to have something like this being generated because of the sort of sensitive area that the I mean, a woman image can be a sensitive topic, and it can spoil the company's image. So you don't want to really generate this kind of data. That is where negative prompt engineering comes into picture. Yeah. This is what a difference is between stable diffusion 1.4 and 1.4 floating point 16. We discussed about FP16, right? So how that comes into picture is, you see the difference between the image, how more and more realistic it is with the FP16 operation that has been used in these newer instances. So the same thing generated via two different in fact the same model just on a two different CPU types, it actually is looking much more realistic here. Then you can also fine tune the models. I mean, yeah, the possibilities, as I mentioned, are limitless. This is a very interesting blog. If you read through, you'll really find it interesting. The next thing I wanted to show was how it can be useful to use Gen AI or the code whisperer that is based on Gen AI for a developer. I have created a Cloud9 IDE, and then I just wanted to show how the code whisperer comes into picture. So you just have a JS JavaScript code. I am not a Java developer at all. As you would have heard, I am an SAP architect. But now I want to just write very simple English, and I don't know the syntax at all. I just want to find some write something and it should show me the code. So I want to print something as an output, right? So this is what I have put as output. And then okay, I think my session has expired. Let me refresh it. One second. Yeah. Okay. Yeah. One second. Why is it not showing now? Yeah. So you see, right? Now it gives me a suggestion already. It is coming from Code Whisperer. You see here. I just want to see how do I get an output. If I just click here, the whole line is already typed for me. I can change this text, and then now I know that if I, obviously it is still having a missing var syntax on the left, but if I have var output, then uh, a input of what is your name would be transferred to the output variable. And I did not know this read line dot question at all, right? The syntax was not known. This has come from with the code whisperer that was running behind the scenes for us. Okay, and then I can simply run the code, and yeah, you see, 1 is 10, and then you can just, I mean, you can do all the usual things after that. But what I wanted to show was not the code. I wanted to show the output, how code whisperer basically plays a role in the in the coding space. Yeah, so that is what I was sorry. Yeah, we looked at code whisperer, we looked at Bedrock, and we looked at Jumpstart. So yeah, these are the things I wanted to show. All of that you have heard in last 1 hour are referenced over here. So I have picked up content and I have tried to give it a flavor that is more understandable. The blogs, the links are there, and also I have put in the LinkedIn and the email addresses that you can reach out to me on in case you want to have any further discussion on any of these topics. I'm not claiming I am an AIML expert, but I would be more than interested to discuss and brainstorm on any of the new topics and see how we can use these technologies along with AWS, right? So I am working closely with AWS colleagues, AWS partner solution architects, who can definitely uh, help us give all sort of what do you call, services available for some sort of demos and things like that in case we have a good use case. Yeah, so that is it. That's what I wanted to cover. I think, yeah, I'm close to finishing that hour, but I'm happy to stay back for more time in case there are any questions, comments, or anything else that you would want to hear from me.
Yes, sir. So we have a question from Ajay Singh Sethi.
Mhm.
He's asking, are generative AI models deployed differently for real-time interface?
Okay, see, Ajay, so trained generative AI model and real-time inference models, right? They are basically at the end of the day, from a technology standpoint, would be deployed in the same way because they are models and they would need endpoints for communication. So there is no difference. The Gen AI model, which I mentioned in Bedrock and services, which are basically readily available. So the differentiation lies between whether you're using a already readily available model and just you want to consume the API, or versus that you are actually creating a model from scratch or probably reusing one of the models but customizing it fully. At the end of it, the inferences would have to be generated via the endpoints, and those you can do it via the SageMaker endpoint service. You can do it via the Amazon Bedrock, which gives you APIs. But all of that would basically run that inference on some of these inference processors, Infertias that we saw, which would basically give output. The way you would see it in Bedrock would be different because you call via API. The way you would see it in SageMaker endpoints would be slightly different. That's the only difference. Yeah. Okay, yeah. Ajay, again, I think another very useful, very important question, because that is the question even I had. Okay, where should I start if I want to get started with Gen AI? If you have a free account, or if you don't have one also, you can just create it, right? And they give it 12 months of free uh, credits for you. Start over here. Amazon SageMaker Jumpstart foundation models. Obviously you will need to do some readings, but then hands on is the best way I would want to learn. So if I have to if I have to learn, I would really just open any of these models. It will sound probably all Greek and Latin. You will not understand anything in the first go, but that happened with me because I came from SAP space, right? Or I still work in SAP space. I really don't uh, do AI ML day in and day out, but if I have to learn AI ML, I have to do some sort of hands-on. That's where I do these kind of reading of the Jupyter notebooks, trying to read what are the comments, and then understanding what is the flow. And there are plenty of them available, right? So AWS themselves give you, then you can go to GitHub, find a lot of them. The other providers for that matter, Azure and GCP, also have similar stuffs as well. Okay, so that's the place to start. Sorry. Yeah, I hope I was able to answer this question. Any other questions for me?
Let's a minute or two. Okay, so no more questions. I think we should sum up this session.
Yeah, thank you, Pratik. Thanks everyone for listening out, and
Yeah,
I hope it was useful.
yeah. Thank you, Sarup sir, for delivering this session, and your expertise and insights have matlab, truly
Great.
have enriched our understanding. And we
Sure.
look forward to host more sessions with you. And
Sure,
thank
Pratik.
you to all
Anytime.
our community members for joining today.
Mm.
We will be back super soon with another session. Until then, thanks.
Thank
Hello,
you. Yeah.
can you hear me?
Yeah, yeah, I can hear you, Pratik.
Yeah. Until then, make things better with AWS. Thank you.
Thank you.
Thank you. Thank you, everyone.